We're going to talk about relations and functions today, but first of all, of course, let's start that lesson opener so you pause and then come back and check your answers.
Okay, let's see how you did. So the first one says simplify the expression. So after you go ahead and distribute, now be careful when you distribute because you have that little negative sign there. Put a little -1 there if you need it. You combine like terms and you should end up with 3h plus 3g. No big deal.
Notice that you don't have anything equals. We didn't get g equals 2. Why? Because it's an expression. You can simplify expressions. You can solve equations, which takes us
to the second one where it says solve the equation. So we're going to end up with a solution here like x equals or a equals. So for this one, after I distribute, I'd go ahead, get my variables to one side, isolate that variable, and I end up with p equals 2.
Essential vocabulary. So remember to get this down. Very important we communicate effectively in math. Relation is a set of pairs of inputs and output values. So everything that we're dealing with today will be a relation. To be more specific within that relation, if we're talking about the inputs, that's the domain. And so if we're talking about an XY ordered pair, the X coordinates are the inputs. And it's also known as the independent variable. Range then, of course, is the output of any relation. In an ordered pair, the Y coordinates, and we call it the dependent variable. We call it the dependent variable because it depends on the value of X. Whatever the input was, then it shoots out the output. So let's get to it.
Did you write those down though? If you didn't write those down, pause and make sure you get these written. Moving on, we have different ways we can represent a relation. Here are 4 good examples of how you can represent a relation. A set of ordered pairs, a mapping diagram, a table of values, or a graph.
Within those, we're going to look at 2 in particular and talk about the domain and range. So that first one, the set of ordered pairs, we have the domain, which is going to be the X coordinates, and we'll just go ahead and list those in order from least to greatest. Very important. We also use that curly Q bracket. That tells us it's a set of numbers. So we start with -2, then 1, and then I see 5 appears twice, but guess what? When I talk about the domain, I only have to write it once. With the range, we go ahead and look at the Y coordinates, same thing, least to greatest, and that means we'll have -7, 11, 21. I did not write the 11 twice. The next one we look at is just that mapping diagram, and we didn't take time to write all this out, but just to emphasize, remember that the inputs are the domain, so that -1, 0, 1, 2, 3, and then the arrows are pointing to the output, so that column is going to be the range. And then similarly, if you look at the table of values, the inputs, you would list that as your domain, the outputs, that's your range. Then we get to the graph. And the graph has a set of points. So sometimes students like to write these out separately on the side, but we can also just stop and think about it. The domain is the X coordinate. So if I walk along that X axis and I look up and down, I can see that the first point I come to occurs when X is -3. So I can write -3. Then I go to the next one, -1, and so on, all the way along. So I end up with -3, -1, 1, 2, 3. When I go to do the range, I look at the Y, and so then I'm going to go walk up the Y axis, and I'll start, and the first point that I get to is over there at -3. So -3, keep walking, I see one at -2, keep walking, 1 and 2. The range is -3, -2, 1, 2.
This brings us to what a function is. Now, a function is just a relation in which every input has exactly one unique output. So like every X maps to exactly one Y.
Right, they can all map to the same Y, but you're never going to see like a 5 going to a -7 and a 5 going to an 11. So if you look at that first ordered pairs, right, that's not a function because 5 is going to -7 and to 11. And then we can talk about a very special type of function, which is a one-to-one function. So once again, it's a function, so we know that each input maps to exactly one unique output. But if it's one-to-one, then each output maps to exactly one unique input. So you don't see repeats either way. So if we look up here at the representations of relations, we're going to go through and kind of categorize everything. I gave away that first one, the ordered pairs, because we already know that's not a function because 5 goes to -7 and 5 also goes to 11. So boo. Now, it's okay that -2 goes to 11 and 5 goes to 11. It's still a function. So a function just doesn't have where the X goes to 2 different Y's. But all of them could go to the same Y.
Moving on to the next one, this one is a function. So in our mapping diagram, we can see that every input has exactly one unique output. But is it a one-to-one function? Let's look at those outputs. No, the output of 1 has 2 different inputs.
So that doesn't work. When we look at the next one, now I think we're going to see a one-to-one function because negative 2.1 goes to only one output, negative 4.2. I'm not seeing any of the x's repeated. I'm not seeing any of the y's repeated. Now looking at the graph, I'm trying to check if it's a function or not. If I look along at that domain, I see we have this unique domain, negative 3, negative 1, etc. And each x value only goes to one y value, which leads us to that vertical line test. So if we want to jump down there, the vertical line test says, if you're looking at any sort of a graph and you draw a vertical line, if it goes through more than one point, if that vertical line goes through more than one point, then it's not a function. So if we look at our graph, it's just a collection of points, but there are no 2 points that occur on the same vertical line. So our graph is a function. But let's look a little bit more at vertical line test and see if we understand it.
Okay, so make sure you wrote down that definition for the vertical line test, and then as I move down to these bottom 3 graphs, the first question is, which are not functions? So if I look down here, I'm just gonna run the vertical line test across all of them. The first one totally passes the vertical line test. Nowhere I draw a vertical line am I gonna pass more than 1 point. Same with the second one. But then I move to the third one, I could draw a vertical line on this one, and I'm crossing twice because it's a circle. It's gonna intersect my vertical line twice. So C is not a function, so I can say that right away. The other 2 are functions, I just need to figure out what kind of functions they are. So when it says which are functions, I'm gonna say A and B, and then one-to-one. Okay, so one-to-one says every input has one unique output, and every output also has one unique input.
So if we have the vertical line test to test if every input has one unique output, could we use a horizontal line test to see if every output has one unique input? Yes, we can. Be careful with that, and I hope we're not giving you too much information. Vertical line test tests for function, and then vertical line test and horizontal line test would test for a one-to-one function. But for the most part, we're just looking at functions. So keep in mind, that's the vertical line test.
Since A and B both pass the vertical line test, I can now run the horizontal line test on them. If I run the horizontal line test on A, totally doesn't pass. I could cross up to 3 times. But if I run it on B, since it's a straight line, I'm only crossing the horizontal line once at any given point. So yes, B is a one-to-one.
And pretty much every line that does not happen to be a vertical or horizontal line is a one-to-one function.
So let's check our understanding here. If I just want to check to see if my graph is a function, what do I do?
We use the vertical line test, and if that vertical line anywhere on the graph goes through more than 1 point, it is not a function.
So then why would I ever need the horizontal line test?
Only if somebody's asking you specifically if it's a one-to-one function. And then we also use it for something later on in class.